to extract. So the easiest thing we can extract first the displacement and inter-story drift. So first, I want to show you how we can display all of this on software itself and how we can extract and draw it in Excel or use anything outside. So for ETABS itself, we have here display, and here there is an option called story response plot. Yeah, this one. It's a very, very good tool to use. So here I can change my load combination. Here I have, for example, I'm caring only about earthquake X and Y. I can choose this one. Yeah, this one. There is a maximum story displacement. When you choose earthquake X, you will find that in X direction, because blue for X direction and red for Y direction, blue starts to go away, and red it's almost in the zero displacement. And you can see the displacement in meter down, the value I mean. Here, for example, the value around 0.36 meter. It's a lot because here we only use, I think it was column very small, and also there is 60 floor. In 60 floor, we should increase column and increase beam and increase of this, all of this stuff. But yeah, we should compare this one by the standard. And by the way, I think not all standard has a value for comparing with maximum displacement. But usually we use H over 500 to compare, but this number is not in all standard. But we are very caring about it, not maximum story displacement, maximum story drift or inter-story drift. This one, maximum story drift. This shape, which I got from where? From getting, for example, which will show now. Yeah, this one. Yeah, this figure. Where can I get this figure? I can get this one. As I told you before, we can calculate the displacement here and subtract this displacement from it and divide it by the H of the story. I can get each value of these number. And you can find down that there is no unit here because it's a ratio between one dimension and one dimension. Okay, so it's unitless. So here we get this number and compare with the standard. So here also you can show more things, like for example, shear, story shears and overturning moment. For example, overturning moment, if you want. But here we don't care about this. We only care about maximum story drift and maximum displacement. And also you can't get it from here. Why? Because here, if you apply, for example, this for this one is overturning moment, and you will find this very small at top and start to increase at bottom, and that's right, yeah, because the foundation, which is can resist all bending moment or overturning model of all building. So, but here we can return back to maximum story displacement. Yeah, this tool is very good to compare the model itself for yourself. But if you want to compare model with other model, you can't use this one because here the x value you can't um, control the maximum value. For example, when I create any figure and I want to compare between different model, I want to fix it the x direction and draw the my figure on it to compare between them. So here to make like this, you only go, so I can close this one now and also go to display and go to show table. And here I want to use um, yes, structure output is the same. And here on this one, yeah, this one. This one I can extract. Um, not this. Yeah, this one. Joint output and displacement. Here I can extract story drift. Okay. And also I can extract the story maximum displacement. I can check these two and here check or make sure that I'm choosing only S quick X and Y and OK and say OK. I think you know how to use Excel, right? Yeah. So now I have here for each story S quick X and S quick Y, and I have the value of drift, and also I have value of maximum story displacement. I can go to file, export to Excel. It should open new Excel file. Yeah, this one. Here we will find, for example, the file of, I think I can extract both of them together. I don't know. But yeah, this file, for example, for maximum displacement. So here you can, for this model, for example, you can say this base model, and you have created another Excel file and take the value from here. For example, if I create here, yes. So what you are caring about this number. You can take this one and take this one, Control C, and go to your new Excel file and say here, yeah, okay, yes. Mm, yes, so you can delete all of them. And you want this number for X direction, for example. Usually for this thing, I don't use Excel. Yeah. Now I have the mm, yeah, what I mean here, for example, you create for the first model the displacement in x direction. You can see here model 1 and start to get from each file you can get out the value of displacement and put it here and say, for example, model 2, and you know what is the difference between model 1 and model 2, and that's it. And after this, you can start to create figure for this value. Go to insert and create figure. Yes. And here I want to make sure that I want the story number to be in y direction and story is displacement to be in x direction. To be like what I showed you before. So here I can go to select data, here edit. For x direction, I want this value and start from bottom to top. And also for y, I want it like this. Yes, it was like this. Okay, and here you will add for this figure another number and another number, and that's it. And the main thing about this one, you here, you can fix this x direction or x values, for example, up to 0.4. So you can compare between each other in the same figure. Guys, also you can use this Excel. I use other another tool like MATLAB or Python. I don't use Excel, but you can use what you want. For example, I will show you shear lag using Python now. But here you can here extract the value of story drift and story displacement in easy way. There is no difference. Okay, only display and go to the option you have here. Yeah, display. Here the joint output, and here the displacement. This is story drift and this story displacement. What else I want? The shear lag figure. So for shear lag figure, we don't have like figure directory or value directory for shear lag, but we know how to create it. We want only the force in Z direction to get out and to create our shape. So here we want the value of Fz or normal force in column, and for example, in first story. So we'll go and check all of this. And here we will go to element output, and here frame output, here column. But first, I should select this column I want. So for example, if I want to draw the shear lag for column for story 1, I want to select them. So the good tool to select them, I can go here to this mark, and I want to select a column from the plane. So here I will deselect the beam. This menu, guys, for showing something and display or undisplay something. It's only for display, and you can use it for many things. For example, quickly here for this model, if you want to show different, because you are modeling here different column, different beam, different shear wall, and all of this stuff, you can here use color section to show model. For example, here I can activate this part and come here, and instead of view by color of objects, I can come here and change it to section properties. and say apply. Yeah, each section you have defined before, it will be show like this. And here for our plane, we want to deselect the beam and column and floor and walls because I want to choose the column and apply. Yeah, now it's very easy to choose what I want. I want to choose the column in plane story one, apply. Yes, and here I can select all of them. No, 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 here, no, no, because here when I go to display, show table, and here I will deselect this one and go to element, frame, column. Look, here I choose column. So anything other than column, I will choose like this. But in the beginning, when I deselect all of this stuff, because for the big model, when you select many things, the model it will be very slow. So that's the only thing. But here, the results is only for the column. So I will say OK. Yeah, you have here, for example, story, column 1, 2, 3, 4, earthquake, and station, and B. All I want this one, and this one, and this one. Okay, and this one. So I can easily make the same thing, export to Excel. I will show you the code I developed already. Yeah, this one. So this one, to start here, I will show you quickly small code I created for using Python code, and I will provide it to you to use if you want, and you can change some stuff, small stuff, but it's different from I created before for my presentation. It's very easy. So here, first thing you should, if you want to use my code, for example, I will say save as. By the way, you can use Excel for drawing all of this stuff. It's very easy. You have column, and here, what you want? You want to know here the name of this column and the force related to each one, and start to drawing like this. So you want to know the name of column. How can you know this one? It's very easy to come here. Oh. I want to know, for example, the column in lower part. I can go here and say display label for frame assignment and apply. Yeah. For example, I want this column to draw shear lag for this edge of column. It's very easy. This can take a lot of a little work from you to organize your name of column in Excel sheet or Python code or MATLAB or anything, but it's only for one time. And after this, the same thing, you will make the same model and extract the forces and draw it quickly. Okay. So here, to use my developed one, I use it to use CSV. Yeah, you should extract CSV extraction and go to, for example, the place you want to put. Yeah, this one. This is the place of my code. And for example, I will say, here, exam. anything. Yes, I will remove, close this one. Guys, before I go to the code, I want to say there is something, another thing here in ETAB you should define before you run your model. I forgot it. It's a diaphragm. For example, here you create model, shear wall alone, and column alone, and slab and beam, all of this stuff alone. So here, as I told you before, you want your force to apply in center of mass. So where is center of mass here? You should define center of mass for the ETAB itself. So here it's very easy. Just go to each floor, okay? And I can share this with you, or I think maybe Dr. Omar will share it again with you. But you will start to choose this floor one by one quickly, and after this, go to this one, define or assign. Yeah, shell, and for shell, diaphragms. And when you save this one, click this one, like for example, the trial version here. Mm, we will use only more 5 minutes. Yeah, here, and we will use this one, D1. Okay, and apply, and that's it. After you apply, you should see something like this. We can here show the diaphragm for this building. Oh yeah, this one. Apply. Yeah, it should be something like this. All the point you have created, it must go to one point, which is the point of force should apply. So now we can go back to uh, our forces. So here I have created a small uh, uh, small code using Python. Yes. So here in Python, usually we start to import some libraries like NumPy, Matplotlib, this one to work with array and all of this stuff, and this one to create image or figures, and here pandas to create or to work with Excel format. And here, just I get the file from the CSV file. I already saved it. For example, we can see here. Yeah, it was EX, right? Yeah, we can say run. I think we can depend on Excel now. Take a lot of time. Okay, guys. So we can finish here. And also, as I told you before, you can use Excel to draw what you want, or as you want, MATLAB or Python, I can share this code to use it. Just you can put the name of your CSV file here and run all of this stuff. But you should know how to work with this stuff. And at end, you will find something like this. Yeah. This one I already created in this morning. This one and the direction, for example, this one, and if I have force like this for this direction, and the second one for the perpendicular or normal direction, you should extract some image or figures like this.